In this video, what we're going to do is we're going to explore a couple of concepts related to scientific notation. The first thing we're going to look at is what exactly is scientific notation. Now, scientific notation usually looks like something like this: 4.8 times 10 to the power of 4. Now, there's three different parts here that make up this number in scientific notation. The first thing that we have is we have this 4.8. And this is what we will refer to as the base. And the base of a number in scientific notation is always going to be between 1 and 10. So it's going to be bigger than 1 and smaller than 10. Now the second part of the number we have here is this 10 over here. Now this is also a base, but it's the base of the power. And this is always going to remain 10. This is always going to be 10. This is sort of one of the key features of how scientific notation works. Now the third feature of a number in scientific notation is this exponent right here. And in this case, the exponent is 4. And this is what's going to help us understand how big the number is. How big is the number? And so the bigger the exponent, the bigger the number. So now that we have these three parts, what we're going to do is we are going to use these three things to help us change a number from scientific notation into what we're going to call standard form. Now to do that, we're going to use a little bit of an in-between here. So we're going to take our 4.8 and just bring it down, and we're actually going to expand 10 to the power of 4. And so really that 1 with 4 zeros after it, or 10 times 10 times 10 times 10. So in this case, that's 10,000. So 10,000 is the same as 10 to the power of 4. And you'll see that that's a 1 with 4 zeros after it. This is what is known as expanded form. Expanded form. Now, we're going to put this into standard form by actually multiplying 4.8 times 10,000. And the best way to do this is to think about when you multiply something by 10, it's the same as moving the decimal one spot to the right. So every time you multiply something by 10, what that means is the decimal moves to the right. And so if we multiply by something by 10 4 times, as indicated by our exponent, the decimal is going to move to the right 4 times. So let's actually do that. We're going to move it once, twice, 3 times, 4 times. And those blank spaces we fill in with zeros. So what we really have here is 4.8 times 10 to the power of 4 is the same as 4.8 times 10,000, which is the same as 48,000. And this is what is referred to as standard form. So let's practice this a little bit. The first number we're going to use 5.12 times 10 to the power of 3. Now, we're going to skip the expanded form and move right to standard form. So to do that, remember we're just going to go 5.12. There's that base between 1 and 10. And because our exponent is a 3, that means we're going to move the decimal 3 places to the right. 1, 2, 3. And we're going to fill in that extra spot with a 0. And so what we get is 5.12 times 10 to the power of 3 is the same as 5,120. What if we wanted to go the other way though? What if we wanted to start with a number that was in standard form, like 937,000, and we wanted to put it in scientific notation? So remember, a number in scientific notation has a base that's between 1 and 10, and then it has this times 10, and then there's an exponent that represents how big the number is. Well, to do this, all we're going to do is we're going to see how many places we need to move the decimal, and in this case the decimal is at the back. How many places we need to move the decimal in order to create a base that's between 1 and 10. So let's do that. 1, 2, 3, 4, 5. After 5 jumps, we have a base that is 9.37 and we had to move that decimal 5 spaces. So 937,000 in scientific notation is 9.37 times 10 to the power of 5. We can also do comparisons with scientific notation. And so let's say we have two different numbers both written in scientific notation, 4.8 times 10 to the power of 4 and 5.12 times 10 to the power of 3. There's a couple of different ways that we can compare these. The first way we're going to do this is by converting these into standard form. So by using the technique that we just practiced, we can change these numbers into sort of regular standard form type numbers. So let's do that. We're going to start with a 4.8, and once again, because our exponent is a 4, that means we're going to move the decimal 4 places to the right, 1, 2, 3, 4, and fill in those blank zeros, which gives us a number of 48,000 in standard form. And then we're going to do the same thing with the 5.12. We start with a 5.12, and because our exponent is a 3, that means we're going to move the decimal 3 spaces to the right, 1, 2, 3. And remember, we're moving it 3 spaces because what we're really doing is multiplying by, in this case, 1,000. And so that gives us a final number of 5,120. So we can see that clearly 48,000 is bigger than 5,120. However, there is a faster way to do this, and the faster way is merely by compare the exponents. By comparing the exponents of two numbers in scientific notation, if they're written properly, we can see which one is bigger. So in this case, we have an exponent of 3, and over here we have an exponent of 4. Since 4 is larger than 3, that means that 4.8 times 10 to the power of 4 is bigger than 5.12 times 10 to the power of 3. And that is two different ways that we can compare numbers in scientific notation.